And so now we're going to shift from that transformative technology to yet another one that we haven't covered yet today, though we've heard a lot about it, and that's long-duration storage. So to help us get into that discussion, I'm going to ask Evan Pittman, the Senior Vice President, Innovation and Commercialization with our partner, Energy Impact Partners, to come up to the stage, and he's going to be joined by Dr. Mark Berry, Senior Vice President, Southern Company Services R&D. Evan and Mark, thank you very much for being here.
Thanks, Eric. Good afternoon, everyone. Appreciate it. I haven't had a lot of chance to hear from the audience yet today. Everybody doing okay? Having fun? Enjoying the beautiful hub space that EEI has created for us here? Good. Well, as Eric said, my name's Evan Pittman. I'm our Senior Vice President of Research and Innovation at EIP. I co-manage the team that at EIP basically has the easy job of picking out the technologies that are going to matter and drive us through the energy transition, and then figuring out how to scale those technologies. And we do that really through super close partnership with the operating units at our utility investors. Any apparent success that we have really comes from our ability to channel and use their insights. So that's the perspective I'm bringing to this conversation today. I'm going to actually moderate you guys through the next two mini sessions. This first one is going to focus on long-duration energy storage. You guys have heard now several presenters through the course of the day speak about the importance of long-duration energy storage in decarbonizing our power supply. We're here answering the question of how do we move large volumes of renewable energy across days, weeks, even months, as we increasingly don't have the baseload fossil resources on the grid anymore that we used to rely on for that year-round energy. We're going to start with a video here. Form Energy, one of the EIP portfolio companies focused on this challenge, was scheduled to be here, but COVID struck and couldn't be with us today. So we'll hear from them virtually. I'll let that roll, and then I'm going to have a conversation with Mark here about a project that Georgia Power is launching in partnership with Form Energy.
First things first, what is Form Energy? Form Energy is a company developing a breakthrough electrical storage technology with the capability of storing several days of electricity very cost effectively. So when we think cost effectively, we think at least a factor of 10 cheaper than where lithium ion is today. So by end of the decade, at scale, we're projecting less than $20 a kilowatt hour install cost at the system level. The technology is very low cost because it leverages very low cost materials, particularly iron, and a process that all of us are very familiar with, the process of rusting and unrusting iron. Really the breakthrough is we figured out a way of harnessing this reaction in a way that is reversible. The technology is low cost also because it's inherently safe. The electrolyte is aqueous and so is non-flammable, and the other reagent is air, oxygen in air in particular. We are also, because of the very low cost and widely accessible materials, we're able to scale up very aggressively by leveraging the supply chains that already exist, in particular the steel supply chain and other commodity materials essentially that go into the making of our battery. We're at the stage of having built small testing devices in the thousands of units and having fundamentally retired the scientific risk at that level, and we're now scaling up to the full-scale cells and modules, looking at a product intent, a prototype, in the next few quarters, which really is the foundational building block of our future storage power plants. The way we go about assessing the value of this solution, in particularly demonstrating utility partners the value of this solution, is the advanced analytics. And so we developed Formware. Formware is an advanced capacity expansion tool that allows us to really solve for the cost minimizing, reliability compliant portfolios of future grids as they undergo decarbonization. We looked at several utility portfolios in the 2030 timeframe in the United States. Very often the result of these exercises is that we see gigawatts the multi-day storage, low-cost multi-day storage, what we call our technology, in their 2030 portfolios, primarily with a reliability function. In other words, several of these utilities are retiring their coal assets, are hesitant about building new gas, they're incorporating more and more renewables, and they're concerned about the multi-day weather events where they may be short in capacity, short in energy, and they would love to have a cost-effective multi-day storage solution to essentially backstop renewables. They also see a value in this multi-day storage solution in combination with lithium-ion in doing the intraday balancing of renewable resources against their load. For any questions, please feel free to reach out, and we'd love to start working with you. Thank you.
Well, Mark, thanks for joining us here today. Can we start out by hearing a little bit about what's your role at Georgia Power and Southern Company?
Yeah, thanks, Evan. Hello, everyone. It's really a joy for me to be here and tell you a little about what we're doing at Southern Company. At Southern Company, I am responsible for the R&D portfolio. We are really trying to leverage technology and innovation to help the company meet its net zero goal by 2050.
Excellent. So why is long-duration energy and storage important to Georgia Power?
Yeah, well, let's talk a little bit about Georgia Power. I was listening to Dr. Michael Weber a little bit earlier, and he was talking about, I think he was trying to say that we're not moving fast enough. And I'll tell you from an operating company standpoint, it feels like we're moving pretty fast. So Georgia Power has reduced its carbon footprint by 60% since 2007. And the way that it has done that is through retirement of coal facilities and switching to natural gas and renewables. So to date, Georgia Power has retired 4,000 megawatts of coal, and in its latest integrated resource plan proposed closing another 3,200 megawatts of coal. Georgia Power is building the first in a generation nuclear reactors, Vogtle 3 and 4, but by 2025, we will double our renewable portfolio with the goal of adding 6,000 additional megawatts of renewable by 2035. So when you think about being able to provide reliable energy, you know, one thing I think about is having BTUs on the ground. And since we're moving away from coal, going to more gas, and putting in more renewables, how do we make sure that we have those megawatt hours available to provide our customers with reliable energy? So as we position to have more renewables, it just seems like common sense that we want to pursue medium to long-term energy storage.
Makes sense. Tell us about the project that you're contemplating developing with Form Technology.
Yeah, so Southern Company has had an R&D presence for the past 50 plus years, and one of our philosophies is learn by doing. And we want to help bring technologies to bear, and we want to help companies bring their technologies and make them available to the marketplace. And we think that a proactive approach to working with technology providers to help them get to commercial status is the right thing to do. We will be following Form is doing a 1 megawatt demo with Great River Energy. They're planning to have that demonstration in 2023. And Georgia Power is planning a 5 to 15 megawatt demonstration in the 24 to 25 timeframe. So that means Great River is going to be about 150 megawatt hours worth of energy storage, and the Georgia Power demo is going to be up to 1,500 megawatt hours of energy storage.
Great. And what was appealing about Form? There's a lot of long-duration energy storage solutions, at least being discussed out there on the market, maybe not developed and certainly not deployed. But what was appealing about Form's iron-air battery approach?
Yeah, I really love that video, and I think it really communicates kind of the value proposition, is long-term energy storage at the right price. So I think what we'll see is there will be a number of different energy storage technologies, whether that's lithium-ion, mechanical or gravity-based, or even chemical-based. But from an electrochemical standpoint, I do think the iron-air battery that Form Energy is pioneering is really going to make an impact in our industry.
Excellent. And I like the utility slogan, learn by doing. What do you hope to learn from a deployment at this scale? And what does success look like to you guys at the end of this project?
You know, from my experience, the first time you go out in the field, you learn a lot, right? You verify, I think we saw in the video, kind of the lab scale approach, and you think you know what's going on, and when you get out in the field, there are some prizes, and then you have to go back and, you know, kind of change it a little bit, and we all know what's likely going to happen. At the 5 to 15 megawatt scale, what we're looking at is demonstrating the operating window. I know there's some value in this project that we don't yet understand as a utility, and that's the part that I'm looking for. You know, the learn by doing means that you learn stuff that's not in the report, and that's why we have that philosophy of learn by doing.
Excellent. And final question for you, any advice you would proffer to fellow EEI member companies as they embark on experimenting with deploying either long-duration energy storage or other sort of novel, deep decarbonization technologies on the grid?
Yeah, I would say jump in there. When we have worked with Form and their Formware, and they talked about the value proposition, that's just one point of view. We all operate unique energy systems, and I think if we collaborate as an industry and we talk about the value proposition, then we can tell Form what they need to be working on, and in the end, we'll have a much better product.
Excellent. Well, thank you so much, Mark. Please join me in giving Mark a hand. And with that, I'll invite John O'Donnell up to join me on stage. We're going to switch gears a little bit here for this next session, and we're going to talk about industrial electrification. I'm particularly excited about this topic because we talk a lot about electrification in the industry, but for good reason, we tend to focus on electric transportation when we talk about this mega trend. And that's well and good because certainly over the past 5 years, it's become increasingly obvious that the clean electron is going to win out in decarbonizing that sector. But there's actually a bigger prize out there if we keep our eyes on it for our industry, and that is the electrification of industrial heat. By some estimates, if we were to electrify all of the industrial heat that's used in the United States, that could lead to actually 4 times the demand growth that electrifying every single light-duty vehicle in the U.S. Could deliver. And certainly the industrial sector are going to be looking for solutions. They account worldwide for 30% of greenhouse gas emissions, and with increasing ESG pressure, increasing desire to do the right thing for the environment, and increasing economic pressure, we're going to see industry hungry for solutions, and utilities and their partners being a very good partner to join them in that decarbonization journey. So we're going to focus the rest of this session on sort of 2 examples of how companies are breaking down some of the economic and technical barriers. That's the other part about industrial electrification that I'm sweeping under the rug. It's really hard, but there's a lot of great innovators out there cracking the tough problems that exist in the space. So first, we're going to share a video from another portfolio company that couldn't be here today, Boston Metal. They've pioneered a technology to produce virgin steel from iron ore and electricity with no direct carbon emissions. We think they're a great example of companies solving what actually ends up being a common problem in industrial decarbonization, and that's that many industrial processes don't just rely on hydrocarbons to produce heat, but they also rely on hydrocarbons for their specific chemical properties. In the case of steel production, a reduction agent for iron ore. So Boston Metal is a great example of a sort of novel electrochemical process that gets around that challenge. Then we're going to spend the bulk of the time having a chat here with John O'Donnell, CEO of Rondo Energy, who sits to my right. They've developed a great technology that helps, it's a heat battery that helps match industrial customers' need for round-the-clock, high-intensity heat with the ability of the grid to deliver cheap, clean electricity. So we'll talk a lot more about that in a minute. For now, let's lower the lights and hear from Boston Metal.
Global steel production has almost tripled in the past 50 years, with 2 billion tons produced in 2021. As the premier structural material in everything around us, demand for steel will only continue to grow. While steel is the foundation of our society, it's also one of the greatest threats to the future of the planet, contributing 10% of global carbon emissions. For thousands of years, humans have burned fossil fuels to produce molten steel. With the growing imperative to halt climate change, steel producers are under increasing pressure from investors and customers to decarbonize what is traditionally a very expensive and complex multi-step process. The steel industry needs a direct, scalable solution to reach net zero on the timeline society is demanding, while keeping costs down and creating value throughout the supply chain. For the hard-to-abate steel industry, Boston Metal is commercializing a disruptive technology that can reach the economies of scale required by the exploding demand for green steel. The company's patented MOE platform provides an unprecedented one-step end-to-end solution for zero CO2 emission steel production. Using renewable energy instead of fossil fuels, the platform can convert all iron ore grades into high-purity liquid metal, providing new value across the steel supply chain. Boston Metal, scaling a revolutionary technology to decarbonize the most important engineering material in the world.
All right, John, let's transition to talking about Rondo a little bit. To kick us off, tell us a little bit about yourself. I know you've been working on clean energy solutions for industrial heat for a long time. So tell us a little bit about your background, and then tell us what was the inspiration that led you to Rondo, the aha moment, and what Rondo does in your words. I'm sure you can describe it better than I did.
Yeah, thank you. I was originally an engineer. My first job was at Princeton Plasma Physics, working on fusion power. Fusion power slipped a little in schedule since the last time I worked on it. In 2005, I started working in solar thermal energy. I brought two different companies, one called Austria that Areva bought in 2009 and one called GlassPoint, from early stage to scale. And one of the obvious things, looking at how do we solve high temperature thermal energy, one approach is concentrating sunlight onto targets. And when photovoltaic and wind power were the costs they were 20 years ago, that was the absolute lowest cost way to do things. But just a few years ago, maybe 5 years ago, 3-4 years ago, wind and solar power have become not only lower cost than any solar thermal technology, and conventional generation. In many places in the world, they've become lower cost than fuel. And we recognized, Rondo started backwards. We started with having worked for 15 years to decarbonize the production of aluminum and lithium and copper and fuels in sunny places in the world. We realized that, no, there was another way to go after that, and electricity was increasingly the obvious foundation. But though low-cost electricity is available and abundant intermittently, and that an energy storage technology to serve those things was going to be needed. There were no solutions in the market. Your CTO earlier today talked about the vast amount of world energy flowing through century-old technologies. Rondo figured out how to combine a 200-year-old technology that you just saw a glimpse of that came from blast furnaces and a 100-year-old technology in a new way to exploit direct use of electrical energy intermittently to heat thousands of tons of brick to several thousand degrees Fahrenheit to deliver a new kind of energy storage to power high-temperature industrial processes continuously, whether you're making baby food or cement, from intermittent power, from the intermittent power that is available in excess and driving negative prices at some times of the year, particularly in some regions, in intermittent power that is available at almost any scale. And we chose materials that are available at any scale. We use really two very humble things, an iron alloy heating wire and the same brick that's used in every high temperature process in this new combination.
Fascinating. What are the earliest or most exciting applications you're pursuing for the technology initially?
Yeah, thank you. I get excited about a bunch of them because there are a lot of places where we can create value for electric utilities who are working with their customers to change how competitive they are in the world market. The European carbon border adjustment has created value for decarbonizing Scope 1 and Scope 2 for American chemical manufacturers. The production of copper, aluminum, lithium, everywhere in the world there is demand for zero carbon product. Every transportation fuel around the world, there is a push to decarbonize it. So we've been focusing early on the places our technology creates the most value, and again, both for the incumbent power generation sources and the particular utilities. Today, we're a small company. EIP and Breakthrough Energy's investments are powering us to deliver our first 100 megawatt hours this year and gigawatt hours next year. But with projects in Australia and Europe, but California and mid-continent US are two really important early markets for us.
Got it. So what do you think, which industries will be the earliest adopters here?
Yeah, we have projects underway today with 4 cement manufacturers building a pilot true zero cement plant that operates on intermittent power, and projects in both in Asia and in Europe in that area. In North America, again, mid-continent, there are 2,000 hours a year of negative electricity prices, wholesale prices in Oklahoma. Yep. You know, there are enormous opportunities for industrial growth and decarbonization at negative cost, while really changing the economics for existing fleet operators in those areas. So, and some of the areas there are chemical and fuels producers. We have miners, fuel producers, principally in California as well.
Yep. Let's double click on that topic a little bit. Why is this a resource that, or a demand that a utility should, or a grid operator should welcome onto its grid? What is particularly well suited about serving this kind of load?
Well, thank you. Great question. So people talk about energy storage from moving power from time A to time B, and obviously that's valuable. We're talking about moving power from time A to replace coal and gas, right? So it's an opportunity for industrials to eliminate their Scope 1 emissions. And we're not talking about electrochemical batteries that have, cost hundreds of dollars per kilowatt to operate. We're talking about using the same electrical heating wire that is in your toaster that costs $2 or $3 per kilowatt. So operating very intermittently and being controlled by the grid operator mean that these energy storage units are going to be taking what would otherwise be excess generation and providing, in some cases, voltage and frequency stabilization, but very significantly price stabilization, and bringing huge amounts of load with no peak demand growth, right? More megawatt hours, more peak megawatts. And that means that in areas where there's a bunch of renewables happening today, the balancing, the swing of those things is no longer on the combined cycle power plant or another resource that was not designed to operate intermittently. These things can become the swing. We have a 1.5 gigawatt project in Europe where the local grid operator will be dispatching the unit. The customer does not say, I want 500 megawatts continuously. The customer says, I want, 6,000 megawatt hours today. You decide when to deliver them. And that operator has offshore wind that's growing rapidly in their area. So oddly, industrial heat through this switchable approach becomes a solution to grid problems, and that those very grid problems become a solution to industrial heat, to customers who want to decarbonize, and you said it earlier, that people who are producing commodities operate on narrow margins. The cost of energy is critical to their competitiveness. And among decarbonization solutions, many of them, things like carbon capture, almost by definition, result in a cost of doing business that's higher than business as usual. And one of the things we're excited about is this intermittent electrification offers a decarbonization pathway that for the end customer is lower cost than business as usual, and has these system benefits as well.
Yep, makes sense. Are you exploring any opportunities to deploy the Rondo technology in a power to power storage cycle? In other words, could utilities deploy this as a grid resource to store excess electrical energy and then convert it to heat and then convert it back to power?
So if you had asked me that question 2 years ago, I would have said, that's crazy. There are more efficient batteries. But one of the things that we have been pulled into projects now in several places is exactly this matter, looking at distressed and retiring thermal generation assets where they are being forced to swing and in some cases being retired. And you look at those things, in a lot of the cases, you've got a plant where, oh, you think the plant only has 10 years of life yet left. But if you look at it, the boiler system might, but the turbine is in great shape. With maintenance, it'll run another 80 years. Converting those plants, converting thermal power generation plants to run on their steam source to be stored electricity rather than fossil fuel is an area that is exploding for us. And so, again, if you'd asked me a couple of years ago, I would have said that seems unlikely, but we're seeing this value that, Europe has some areas where as you are retiring thermal assets and bringing on renewables that are powered by inverters, you need new synchronous condensers. You need new sources of inertia in the system. Keep those plants that you have today. Keep those jobs that you have today. And also keep that reliability you have today, because that thermal plant can be an asset when the wind don't blow and the sun don't shine and the grid is in demand, that the same asset can be an intrinsically self-firmed energy storage unit. So again, it's outside industrial heat, which is our prime focus, but it is an area of real interest. And I think EIP, you have helped us tremendously in connecting with the industry to figure this one out.
Well, you teed up my next self-serving question, which is, how have you found it important to work with utilities early in the research and development cycle of your product?
What we're doing is valuable only to the extent that electricity, intermittent electricity, is valuable, right? And we need to understand not just what are market conditions today, but where are markets headed? How do we fit in? There's almost no case where we can approach an end customer without a utility partner or a renewables developer partner, and understanding the big picture and understanding where should we be focusing, both who wants to move early, but what should we be doing longer term? The connections that EIP has helped us build with the industry and the work that we're undertaking now, we're actively hiring out of the industry right now to build our capabilities, both in Europe and the US.
Excellent. Appreciate those kind words. What anything that we haven't covered that you feel we need to share with the audience?
Well, there's a long list. How much time do we have?
Well, let's say 30 to 60 seconds. So anything we haven't covered or any call to action that you'd like to leave?
Well, I guess there are two things. One is, one of our advisors says, look, Rondo is a new tool in the toolbox. We are half the capital costs of and half the electricity use of hydrogen, and we can serve many of the applications that people thought only could be served by hydrogen. So one of the things we want to understand is, how do we fit alongside people's existing pathways in that area? We have a lot to learn, and we want to understand, how should we engage? Where is it that we engage with? Is it with innovation groups? Is it with folks who are looking at the existing fleet? And obviously we have a short-term focus. I can serve only a limited number of folks in next year and the year after. But we know that what we're doing has a long-term focus, and we really want to understand deeply, how do we line up with folks' decarbonization strategy? Because again, you all build houses, we build a useful hammer in building that house. And we need to learn where and how do we build that tool to best suit.
Yep. Join me in thanking John for his comments and insights. Thanks, John. Well, thank y'all very much. Just to sort of share some concluding remarks here from the EIP perspective before I hand it back to EEI. Thanks, John. I think there's really one key theme that jumped out at me throughout this day, and that's that, yes, there's a ton of capital and a ton of brain power going into developing these new technologies that are going to help us get to net zero, but they cannot and they will not scale without deep, meaningful collaboration from industry incumbents. That starts at the earliest stages of R&D, like we were just talking about with John. In order for venture to fund these technologies, we have to de-risk the development process in every way possible. That means early conversations, understanding what customers are going to need. It means shrinking the number of years that a company is going to have, that we have to support a company until it sees its first dollar of revenue. But the collaboration really ramps up in importance at the stage of deployment. I loved Mark's comments there, utility attitude of learn by doing. Jigger mentioned it earlier today. Michael Weber mentioned it earlier today. We learn and technologies advance by putting them in the field and learn by doing and find efficiencies, learn how to develop and deploy these technologies. That's what drives things down the cost curve. We've seen it time and time again in the EIP portfolio. We hatch a plan for a product with our company. It's not until we get in the field that we discover the use cases that are going to be meaningful and endure for that product. So fortunately, I've been really encouraged by conversations here. I'm continuously encouraged by the progress I see at utilities that I work with at EIP in sort of changing their culture across their organization to reward measured risk-taking, looking at ways to deploy innovation budgets to help take the burden off of some of their operating businesses to try these new things. So I'd really encourage us all over the next couple of days to have meaningful conversations about that, all of us to reflect on what are the barriers in our organization that keep us from working with some of these innovative emerging technology companies. And let's chat over drinks, let's chat between sessions, let's learn from more panelists and try to crack this nut for our industry. So anyway, thank you all for your time and attention. Thanks to EEI for giving us the honor of co-hosting this great innovation space, the hub here. And with that, Eric, I'll hand it back to you.
Great. Thanks, Evan.
Thanks.